হ্যাঁ হ্যাঁ, ওই ছেলেটাকে বলুন জয়েন করে দিতে। সমস্যা। হ্যাঁ, শুধু দেরি করছে। কিন্তু 4:30 বেজে গেছে তো। জয়েন করলে আমি স্টার্ট করে দেবো, শুধু শুধু না দেরি হচ্ছে। So just waiting for the student to just come to join. হুম। Okay, just like see. কি দেখছো? করছে ছেলেটা? ও, হ্যাঁ সে তো ঠিক আছে। তুমি তো ছিলে না। আসল ছেলেটা, আজ স্টুডেন্টটা কি করছে, এত দেরি করছে কেন? হ্যাঁ, এটা বড় করে দাও, এটা স্ক্রিনটা একটু বড় করে দাও, ছোট হয়ে গেল। জয়েন করছে। নাহলে আমি আমার একটা পড়াবো, আবার পরের দিন আমার বুঝতে পারবো। আবার সেটাকে জিজ্ঞেস করবে, স্যার এটা প্রবলেম আছে, এই problem আছে। আমার পড়াতে হবে সেটা। কেন? সৌরভ না? Okay, just let us start just this portion of that. Newton law of motion. You see, just like see, whenever I'm just going to discuss about the Newton's law, just because we have become the familiar with the concept of that vector addition and subtraction, all these things we have just become familiar. Similarly, now we have to discuss one thing, that is that the main concept of the force. Okay, and the Newton's law is connected with that concept, the force. So what is this force actually? You can see that the Newton law is directly connected with the force. So now see, whenever I'm talking about the force, F force, what it is required, why the force is required, whenever I'm just going to think about an object is at a certain position and it is placed at a certain position and it is placed on a table or something else. So what the thing is going to happen here, if I'm just going to, if it is at rest, if I'm going to apply some force, it's changed the state, it change the state. Saurabh, hello.
Yes,
Saurabh,
sir.
Saurabh, just today, so you're late today, Saurabh? Huh? Saurabh,
Uh,
try to join now within 4:30, okay?
okay, sir.
Okay, now see, Saurabh, we yesterday in the last class we discussed the component I cap, J cap, all these things we have discussed now. You remember?
Yes, sir.
Just try to every
Yes.
day revise these things. Okay, just like if I'm going to have a vector like this vector r, it is having a component this way, r cos theta, isn't it? And
Yes.
this is r sine theta. So if I'm going to take this my x-axis, this is my y-axis. So vector r can be represented as r cos theta I cap plus r sine theta j cap, isn't it? Because this component
Yes,
is
sir.
along x-axis, so we can put the I, and this component is along y-axis, we can put the j cap. Okay, no problem.
Okay.
Huh?
No, sir.
Very good. So now see that Saurabh, we discussed this thing now, just projectile straight. We projected a particle straight upward, is gone to maximum height, again returns back. These things we have discussed, isn't it?
Yes. Yes.
Very good. So now just we are going to apply this vector component rule, this vector component properties, whenever we are projecting a particle not straight, just in an inclined manner. Okay, we will see. That is called projectile. That is called projectile motion.
Okay.
Projectile motion. 1 second. That is called projectile motion. You can see, Saurabh, what the thing is that suppose an object is thrown with a velocity u, angle theta, isn't it? With a velocity u, angle
Yes.
theta, and this is horizontal direction, this is horizontal x. So what we can see that this, whenever we project it with an inclined manner, the u can have a component u cos theta, and this u can have a component u sine theta, isn't it? U cos theta.
Yes, sir.
This velocity has two components, cos theta and sine theta component. So now see, whenever I'm just going to consider the x-axis horizontal component, I'm going to, so in this direction, is there any gravitational force is going to act horizontally?
No, sir.
No gravitational force. Therefore, no gravitational acceleration or retardation. But whenever I'm going to see the vertical direction, acceleration due to gravity is going to act downward. G is going to act downward, isn't it? Check now.
Yes, sir.
Yes, that's why. So now you can see that the projectile is just going to just move like this way. It is in an inclined path, it will start motion in an inclined, just like in this way, it is a curved motion, curve. Okay. So it is inclinedly projected, it will start motion in a curved path. Okay. So now if I see if I see that in motion along x-axis, I can write, because in the x-axis there is no acceleration or retardation, because no gravitational force is going to act. We can see it is a constant velocity motion, u cos theta into t. Displacement along x-axis is equal to velocity into time. Sure?
Yes, sir.
This is the component of the velocity, horizontal component, into time. So this is my first equation. Clear? Then if I just going to take the y, this is my y-axis, this is the y-axis. If I write y, then acceleration due to gravity is downward. So you can write u sine theta into t minus of half gt square, isn't it?
Yes, sir.
So the u sine theta is the initial vertical velocity, vertical component, initial vertical component, because u is the actual velocity, it is having a component vertically upward, so that is the u sine theta. So u sine theta t minus half gt square. Check.
Yes, sir.
Very good. So now see what the thing is going to happen. If I want to make a relation between this x and y, this x and y are variable, they're changing variable. Why variable? Because you can see time is changing, therefore x and y both are changing, isn't it? Since the time is changing, x is also changing, y is also changing. ठीक ना? Clear?
Clear.
So therefore we want to make a relation between x and y. If I able to make a relation between x and y, that will be the equation of this track. This is a track through which the particle is moving. Whenever we project it, this is a track through which the particle is moving, and we want to find the equation of the track, but trajectory. Clear? So
clear. Yes.
Okay, so therefore the time can be represented as x divided by u cos theta from the first equation, because I want to find the time, x by u cos theta, I've got the expression. Similarly, y I can write u sine theta. Instead of this t, I'm going to replace by this one, x by u cos theta, x divided by u cos theta, take minus of half into g, x divided by u cos theta whole square. Clear? Sure? Understanding point? No problem. Then u cancelling out, x into sine theta by cos theta, tan theta, minus of half into g x square by u square cos square theta. Okay, you see, just like, see, this is the, Saurabh, can you hear me? Hello?
Yes, sir.
Yeah. Okay, see, this is the equation of the trajectory. This is the path through which the particle moving. This is the path through which the particle is moving. Okay, no problem. Acha. Now
No.
see, very good. Now see, Shora, if I'm going to, if it is information is given, one information is given that one vertical height is given. Suppose a special vertical height is given. Suppose this is y1. It is given. You can put it here, y1, isn't it? If I
yes, sir,
y1, and this theta is given, g we can take 10 meter per second square, and u is also given, velocity. Okay, then
okay,
you can see that the total expression is going to become a quadratic equation of x now.
Yes, sir.
Because y given, theta given, g given, u given, then this total expression is going to become a quadratic of x. So if I solve that
yes,
quadratic equation, I am going to get 2x. two value of the x. Simple, because quadratic equation solution means two value of x. Simple thing. Understanding my point or not? Understanding that?
Yes, sir.
So what is this 2 point? First of all, see, Saurabh, I can get this point 1x, where this one y is given. This is, suppose this is y1, this length, and I can get another point here, same y. So this is another x from here to here. From here to here, I will get the same y. I will get another x. Understanding my point? These two x's,
Yes, sir.
these two x's can be found. We can find from solving this equation. Understanding my point? Or this kind of question can be asked. So solving this
Okay,
equation,
okay,
quadratic equation, I can find two position of the x where the vertical y is same. Clear? No problem?
clear. No, sir.
Very good. Actually, Saurabh, this equation, the equation of a track, that equation of track through that track the particle is moving, it is a parabola.
Yes, sir.
This is a parabola. Parabola is special, just like a circle is a special curve. It's similarly parabola, hyperbola, it is a mathematical curves. Okay, so this curve is parabola. Okay, very good.
Yes, sir.
Okay, now Saurabh, see, from here, if I observe the motion of the particle, the initially particle started like this way, then it is just going, inclination is changing now, and whenever it is reaching the top point, totally it is becoming horizontal, the velocity is becoming totally horizontal, then again it is coming
Yes,
down. Check.
yes, sir.
Very good. So initially, Saurabh, velocity u can be written as u cos theta I cap plus u sin theta j cap. 1 second. হ্যাঁ উত্তম বাবু বলুন। হ্যাঁ 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 ক্লিয়ার করে দিন। ঠিক 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 ওটা ক্লিয়ার করে দিন। হ্যাঁ 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 একদম একদম ঠিক ঠিক ঠিক। তাহলে so you can see that u is equal to u cos theta I cap u sin theta j cap, because u cos theta is the x component, u sin theta is the y component, isn't it? Now
Yes,
after t time, suppose the particle at this position, particle initially thrown from this position, now at a certain after time the particle at this position. Okay, so what will happen? Because u cos theta, this component is not going to change. Horizontal component will not change, because in the horizontal direction no acceleration, no retardation, but the vertical component is going to change. What is the vertical component? After t time, vy, if you think the vertical component is velocity along y-axis, my vertical component, I can write u sin theta minus of gt, isn't it?
yes, sir.
And what should be the horizontal component? Vx. What should be the horizontal component? It is u cos theta, because u
V.
cos theta is not changing, isn't it? So u
Yes, sir.
cos theta, very good, u cos theta. So this is vx, the vi. So if you are asked to just write the expression of the velocity after t time, sort of how can you write? We can write the velocity at the time t, when the projectile fired. After time t, the expression of the velocity is equal to vx I cap vy j cap, isn't it? So
Yes,
velocity
sir.
vx can be written as this much, u cos theta I cap, and velocity along y-axis u sin theta minus gt, u sin theta minus gt j cap. This is the velocity, expression of the velocity after t time. Saurabh, understanding Saurabh?
Yes, sir.
Very good,
Got it, sir.
very good. Acha. So now see, how can I represent the resultant? At this instant of time, the velocity, it is having a resultant velocity like this way. It is having a resultant because it is having a horizontal component, it is having a vertical component. If I just combine these two, I can get a resultant velocity, na? Sure.
Yes, sir.
So how can I find this?
Yes.
So velocity resultant, I can write like this way: root over of Vx square plus Vy square. Since these two vectors, Vx and Vy, mutually perpendicular with each other, so directly I can use this formula: Vx square plus Vy square root resultant velocity. If this is Vr,
Yes.
resultant velocity. Tick. Sure. Understanding the properly?
Yes. Yes, sir. Got it. Got it, sir.
Okay, very good. So now just writing this expression, we want to write the expression like this way. We want to, this Vr, we can write like this way: Vx, directly put the value u cos theta whole square plus Vy. Okay, so Vy মানে u sin theta minus gt whole square. Bas. So this is the velocity Vr, resultant velocity after t time the projectile is fired. This is the velocity. Is it clear, Saurabh?
Yes, sir. It's clear.
Very good, very good. Now see, can you tell me, Saurabh, initially the particle fired making an angle theta with this horizontal direction, theta. Thick.
Yes, sir.
But after t time, is the angle remains same? No.
Sir.
Can you see now? This angle is changing. This angle, you can see. Suppose after t time, this angle is alpha. This angle is alpha. I'm thinking that this angle is alpha. Mane, the resultant velocity Vr making alpha with the horizontal direction. Just like this is Vr, this is making alpha. So this direction u cos theta, and this direction u sin theta minus gt. Isn't it?
Yes, sir.
So what should be the inclination? How can I find this inclination? This perpendicular by this length horizontal component. So you can see that tan alpha is equal to perpendicular component by horizontal component. What is this perpendicular component? U sin theta minus gt divided by horizontal component u cos theta. Can you see, Saurabh?
Yes, sir.
U sin theta
Yes,
minus
sir.
gt divided by u cos theta. This is tan alpha. This alpha is instantaneous inclination of that velocity with the horizontal. That inclination is going to depend upon time, gt. This t is existing here. U sin theta minus gt. That's why we can see that this alpha is going to depend upon time. Understanding my point? Any confusion, you ask me. Shora, if you have any confusion about this one, instantaneous inclination, you ask me immediately. Shorab, am I audible? Can you hear me? Hello? Hello? Shorab, am I audible? Can you hear me? Some problem has arisen. Shorab? Hello?
Hello, sir.
So you disconnected, na?
Yes, sir. Due to network problem, I have to
Yeah,
disconnect.
some network. Okay. Up to this point, it is clear, na? Up to this point?
Yes, sir.
Very good, very good, very good. Now see, this is instantaneous inclination and this is instantaneous velocity, resultant velocity. This is dependent upon time. So if the velocity is we want to represent in a I cap j cap form, So we have to represent like this way. And if I want to get the resultant, we have to represent like this way. If I want to get the instantaneous inclination, we have to represent like this way. Bas.
Okay, sir.
Still, if you have any confusion, immediately ask me, Saurabh. If you still have whatever we've discussed, if you're thinking that, sir, this is the problem I'm having, I will discuss now. Any problem there?
No, sir.
Very good. So can I change the page? I'm changing?
Yes.
Very good. You written now? You're writing now?
Yes, sir. Yes, sir.
Very good. Very good. Now see, whenever I'm going to think that the projectile like this way, projected, and the particle gone and striking the ground like this way, the particle projected like this way, and this angle is theta, initial velocity u. So you can see in the top point, vertical component of the velocity lost, vanished. Vertical component, but horizontal component existing, isn't it?
Oh, yes, sir.
Why? Just like see in the previous case, we projected with the velocity u. The velocity can be represented u minus gt. So in the top point, when it reached the top point, the vertical component, this vertical velocity becomes zero, na? Same
Yes,
thing.
sir.
Same thing is happening here also. At the top point, so this u sine theta, this is u sine theta minus gt is equal to vy. This becomes zero in the top point. So 0 is equal to u sine theta minus gt. Therefore, what should be the time? U sine theta is equal to gt. Therefore, t is equal to u sine theta divided by g. So this is the time to reach by the particle to the maximum height. U sine theta by g. Simple. Clear? No problem.
Yes, sir.
Very good. Now see what the thing is going to happen here. Whenever I'm writing the y, u sine vertical displacement, u sine theta u into t minus of half gt square. This is the y, u sine theta into, because u sine theta is the first vertical component, ut minus half gt square. That's why u sine theta into t minus half gt square. Saurabh, when the particle started the motion, what is the y? Zero, na?
Yes, sir.
And when it is reaching this point, then also it is zero.
Yes, sir.
That's why we are putting zero. The two extreme positions, starting position, end position, both the cases, that displacement, the y is zero. Therefore, u sine theta into t minus of half gt square. Saurabh, can you see? It is a quadratic of the time, na? Quadratic.
Yes.
Yes. So you can take the t common, u sine theta minus of half into g into t, that is equal to 0. Two factors are there. First factor t and second factor this one. Take first factor t, another factor this one is a quadratic. That's why. So we can take t0 first factor, this one, because the product of these two is equal to 0. So either this is 0, but this part is 0. So we can
Yes.
write like this way. We can write like this way. J t is equal to 0, or t0 means what, Saurabh? It's starting the motion. When it is starting the motion, t0 time 0, then also height to 0.
Yes, sir.
Yeah, yes. So therefore, the next part, this part, u sine theta minus of half gt is equal to 0. we can write u sine theta is equal to half gt. Therefore, we can write 2u sine theta is equal to gt. Therefore, the time is equal to 2u sine theta by g. So this is the time. So what is this time? When it is again returning back to the ground, then vertical y displacement is zero though, isn't it?
Yes, sir.
So this is the time of flight. What I can tell? This is the time of flight. This is the time of flight. Total time required for the particle started from here and comes to this again to the ground. The total flight time. Take.
Okay, sir.
Okay, very good. Acha. So this is completed. Now, Saurabh, if I want to find the maximum height, I want to find the maximum height. Okay, so how can I find? We can find like this way. Vy square is equal to u square minus 2gh. What is the u? U sine theta. U sine theta whole square minus 2gh. V square is equal to u square plus 2as, that formula.
Yes.
So when it is reaching the maximum height, what is its velocity? Zero to vertical velocity.
Yes, sir.
So 0 square is equal to u square sine square theta minus 2g capital H. This is capital H. Therefore, the H can be written as H we can write, solving this equation, u square sine square theta divided by 2g. Maximum height. This form u square theta by 2g. Achha. I think it is clear, isn't it?
Yes, sir. It's clear.
Very good, very good, very good. So u square sine square theta divided. So we got an expression of the maximum height. We got an expression of the total time of flight. We got the expression of the time to reach the maximum height. And in the previous portion, we got the equation of the track. We got the instantaneous velocity, expression of the instantaneous velocity. We got the instantaneous inclination. We got instantaneous inclination. We got instantaneous velocity. And we got the equation of the track. So up to this point, I think it is clear to you.
Yes, sir. It's clear.
Very good. So now, Saurabh, we got an expression of the total time of the flight. The particle going up, again coming down, that is called total time of flight. Okay. So now we are going to find what is the total horizontal distance it has traveled from this position to this position. Horizontal displacement. Because vertical displacement to zero. Vertical displacement zero. It has gone up, again returned back. So it is a vertical displacement zero. But horizontally it has shifted from this position to this position. Check. So now we are going to see that this we want to find. This is called R. This is U. This is theta. So therefore, in this direction, the velocity, horizontal direction, U cos theta. Horizontally, there is no component. Component of the acceleration. Any acceleration retardation there is no. So x we can write u cos theta into time. Therefore, the total time required to come from this position to this position, it is called the total time of flight. So we can write x is equal to u cos theta into 2u sine theta by g. Therefore, u into u square by g into 2 into sine theta into cos theta is equal to total length from this position to this position. This is called horizontal range. So we can write u square by g sine 2 theta. This is the range. Saurabh, see, any confusion is there or not?
No, sir.
Clear, very good. So this is the horizontal range we are getting from here. Okay, very good. So now see, can you tell me, Saurabh, if I just going to assume that what is the velocity with which we are projecting u? It is fixed. Acceleration due to gravity, it is fixed. Acceleration due to
Yes.
gravity, it is fixed. U, the velocity with which we are throwing, that is fixed, not changing. So what
Yes, sir.
should be the angle with which if I throw, I will get maximum horizontal range? Can you tell me?
Yes, sir. Could you repeat the question?
Now I'm telling that what is the angle with which if I project this particle, I will get the maximum range. Mane, the particle will reach the maximum distance.
Sir, if we project it perpendicular.
Perpendicular.
Yes, sir.
Perpendicular mane you just going to tell this straight.
Yes, sir.
So it will go straight and it will fall straight. There will be no displacement.
Okay, sir.
Okay, understanding my point?
Yes, sir. Yes, sir.
So there will be no displacement. But we require this displacement, this much. And when the displacement is going to become maximum, that's the condition we want. Okay, the question understood now?
Yes, sir. Understood.
So now u to fixed. The velocity with which we can throw, that is fixed. Acceleration due to gravity fixed. So now when sine theta is going to become maximum, when the sine theta is going to become maximum, then that range is going to become maximum.
Okay, sir.
Understood? Very good. So when the sine theta can become maximum, this sine value of the sine can become maximum. The value of the maximum value of the sine is +1. You know this thing, Saurabh. I think you know.
Yes, sir.
Yes. So now when the sine 2 theta is going to become +1, then what the thing is going to happen? This 2 theta is becoming 90 degree.
Yes, sir.
Yes, this 2 theta is going to become, because sine 90 mane +1. Value of the sine 90 mane +1. So now 2 theta is going to become 90 degree. Then theta is going to become 90 by 2 mane 45. So if I project the particle with the angle of 45 degree, it is going to reach a maximum distance.
Yes, sir.
Understood, Saurabh?
Yes, sir.
Very good. Now, just I'm asking a question. Once in a NEET, the question was asked. You see, India-Pakistan firing is going on.
Yes, sir.
Yes. So artillery is fired. Artillery means just cannon. From the cannon, cannon guns are fired. Okay. And
Yes.
that projectile is like this way. That shell is fired and it goes and striking to the enemy region. Okay. So now,
Yes.
if I want to get the maximum range, that shell should be fired at an angle
Yes.
45 degree. We found it should be
Yes, sir.
fired. So now question was that in the NEET, velocity u is the velocity with which the shell is fired. So
Yes,
what
sir.
should be the maximum area? What should be the maximum area gun can cover? What should be the maximum area the gun can cover? Suppose at this point the gun is situated. at a certain point. It is a big field at a certain point. Gun can fire this direction, gun can fire this direction, gun can fire this direction. Any direction gun can fire, na?
Yes, sir.
So gun can cover a certain area. Gun can cover a certain area, region. If it is firing this direction, it is reaching this point. If it is firing this direction, it is reaching this point. So it is certain area. That maximum area we have to find. Understood?
Yes, sir. Understood.
Very good. So how to find? Now see, whenever that the gun is firing, the maximum range value is what? It is fired at a 45 degree. The range value is u square by g sine 90. Sine 90.
Yes, sir.
So now the maximum range R max is equal to becoming u square by g. Simple. So in every direction, this maximum range is possible in every direction. Because gun can fire, gun can be fired in any direction.
Yes, sir.
Okay, man. So therefore, this is the radius. This is the radius. So we're just going to take that radius like this way. Anything problem arising?
Yes, sir. Screen is not visible.
Oh, screen is not visible. Acha. Oh, yeah.
Yes, sir. Now visible.
Now visible? Okay.
Yes, sir.
Yeah. না স্ক্রিনটা হঠাৎ চলে গেছিল, এখন আবার এসছে। ঠিক আছে, এসছে। স্ক্রিনটা হঠাৎ করে ইয়ে হয়ে গেল, মানে ডিস্টার্ব হয়ে গেছে। Okay, ঠিক। So now, Shurab, see, so by taking the R max, what is the maximum range as my radius, if I develop a circle, that is the maximum area that gun can cover, isn't it?
Yes, sir.
Bas তাহলে pi into r max square, তার মানে pi into, just put the value, এই যে u square by g, put the value u square by g whole square. Therefore we can write pi u to the power 4g square. The area, maximum area max, so this is pi u to the power 4g square. The gun can cover this much of maximum area. Is it clear or not clear?
Yes, sir. It's clear.
It is clear. Very good. Okay.
Yes.
Okay. Ayush Raj, a new student, has joined. Ayush, can you hear me? Am I audible to you?
Yes, sir.
Okay, fine. So you understanding? Just we are discussing some two-dimensional projectile motion. Are you getting my point? What is discussion is going on?
Sir, I have just joined the class.
Okay, no problem. So if you have the doubt or confusion, later you can ask me. Okay.
Okay, sir.
Now see, so this is the thing we have seen. Now, like we got the expression of the horizontal range like this way, u square by g sine 2 theta. We got the expression like this way. This is theta, and like this is u cos theta. This is vertical component u sine theta. We got range is equal to u square by g sine 2 theta. Now see, if I just little bit simplify this one, the range I can write like sine. Sure up, you started trigonometry though? Little bit.
Yes, sir.
Yes. So sine alpha, can I write 180 minus alpha? You know, na?
Yes, sir.
Same thing. The sine 2 theta is equal to 180 minus 2 theta. Simple. Therefore, u square by g. Now, sine, if I take 2 common. 90 minus theta I can write if I just going to take 2 common from these two.
Yes, sir.
Right. So let's think this. Let us think that alpha is equal to 90 minus theta. Let alpha is equal to 90 minus theta. So we can write alpha plus theta is equal to 90.
Yes, sir.
So 90 minus theta mane alpha. So we can write like this way: u square by g sine 2 alpha. Check.
Yes, sir.
Very good. So u square by sine 2 alpha. This is 2 alpha. So alpha and theta, what is the relation between them? They're complementary angle.
Yes, sir.
So what the conclusion we can find from here? Because if I project the particle with the angle alpha, what the horizontal range we are going to get? If I project the particle with the theta, the same horizontal range I'm going to get, isn't it? I'm going to get same range.
Yes, sir.
Yes. So now you can see that just think about, suppose theta is equal to 30 degree. If the theta is equal to 30 degree, so what is the alpha then? 60 degree.
Yes, sir.
Because theta minus 30, 90 minus 30 is equal to 60 degree. Therefore, now a particle, if it is projected with the 30 degree, it is reaching at this position. If a particle is projected with the 60 degree, it is going to reach the same position. Both are projected with the same speed, naturally, same. But if the angle of projection, one is having 60 degree, this much, one is having 30 degree, this much, but where it is going to strike the horizontal position, that is going to become same horizontal range.
Yes, sir.
Understood or not?
Yes, I got it.
Got it? Very good. So this is the proof. Just we can see from this situation that complementary angles. So with the complementary angles, if I project the particle, it is going to reach the same position. Okay. Now, Saurabh, can you tell me, in these two projectile 1, projectile 2, range the same, horizontal range?
Yes, sir.
What is difference?
Sir, the height they are reaching.
Yes, this height, it is having lower height, it is having higher height. Yes, first point. Another point. Another point. What can be another point, Saurabh? Time of flight. Time of flight. Okay. Because we got the time of flight 2u sine theta by g. 2u sine theta by g. Just like, see, just we derived expression of the time of flight. Okay? 2u sine theta by g.
Yes, sir.
So when the angle is going to change, time to reach the ground, it's going to, if the theta is changing, time is changing. Simple, isn't it?
Yes, sir.
Very good. Very good. So now this is the difference. Yes. Now, show up a little bit, just mute.
Okay.
Now, this is the range I'm just going to find. So we found this thing, and also we found. Now see. Suppose this projectile fired with a velocity u, it is again striking this position to the ground. It is striking the position with the ground. Horizontal velocity u cos theta is not changing. U cos theta not changing, but the vertical velocity is going to change. Initially, the vertical velocity was u sine theta. but whenever it is returning back, the velocity just gets reversed. Just reversed. Reverse direction.
Yes, sir.
So now, can you tell me what is the change of momentum has occurred due to this motion? What is the change of motion has occurred due to this one?
Sir, the change of momentum, that means
Momentum মানে momentum হচ্ছে mass
yes,
into
mass
velocity.
into velocity.
Mass into velocity. This is a change. So Saurabh, whenever the particle projected up,
Yes,
inclined in an inclined way, vertical component u sine theta. When it is striking the ground, vertical component also u sine theta, but downward, just downward, reversed.
yes, sir.
So now you can express the momentum mass into velocity মানে initial velocity, if I can going to take this is ui, initial velocity ui can be written as u cos theta I cap u sin theta j cap. ठीक, u cos theta I cap plus u sin theta j cap.
Yes, sir.
Now final velocity, this is my final velocity, this is in this direction, u final uf, if I think uf velocity uf, so uf can be written as uf minus u cos theta I cap plus u, no sorry, u cos theta is not going to change, u cos theta I cap minus u sin theta j cap, because this vertical component has changed, direction change, that's why minus u sin theta. Take.
Yes, sir.
Therefore the momentum change মানে mass into change of velocity delta v. This is called change of momentum. Change of velocity multiplied by the mass, it is called change of momentum. Take.
Yes, sir.
So how can I get the change of momentum? This final velocity minus initial velocity, if I subtract these two, I will get the change of momentum. But
Yes,
change of
sir.
velocity, then if I multiply with the mass, I will get the change of momentum. So final uf minus ui, uf minus ui, what I can get, Saurabh? So uf, u cos theta I cap, u cos theta I cap, cancel out. Cancel out.
Yes.
Minus u sin theta j cap minus of this u sin theta j cap মানে minus 2u sin theta j cap মানে minus 2u sin theta j cap. This is the change of velocity. Is it clear?
Yes, sir. Clear.
তাহলে so we can tell that the change of momentum, it is m into delta v. This is uf minus ui, this is the change of velocity delta v. Okay, so m into minus of m into minus of 2u sin theta j cap, ultimately it can be written as minus 2m u sin theta j cap, minus 2 mu sin theta j cap.
Okay, sir.
This is a change of momentum
Yes.
during the total motion. Clear? I think clear. Saurabh, it is clear. I think it is clear, isn't it?
Yes, sir. Yes, it's clear, sir.
Very good, very good, very good. Okay, so this is the okay, fine. Now see, like yeah, like you can observe, just I'm changing the page, huh?
Okay, sir.
You can see that suppose a projectile is fired, it is going up and is coming down, okay, and
Yes.
it is the angle theta, u is the velocity, this much of velocity existing here. Tora, can you tell me at the top point, I'm writing some expression of the velocity, okay?
Okay, sir.
Option 1, u cos theta I cap plus u sin theta j cap. Option 2, u cos theta I cap. 3, u cos theta I cap plus u sin theta minus gt j cap. Option 4, none of these. What should be the option? Sure. Velocity, expression of the velocity v. Which one is the option? Ah.
Yes.
Which one is the
The
option? One.
magnitude value will be 0, so as it is in that direction. If we take the formula, then it should be u cos theta I cap plus u sin theta minus gt j cap.
Now I want the velocity expression at the top point.
Okay, sir.
So your option is option 3. You're telling.
Yes, sir.
Okay.
Little bit confused at number 3 and number 2.
Just you have the confusion either 2 or 3.
Yes.
Acha. Ayush, can you tell me any idea? What can be the option here? I want to get the velocity expression at the top point. I've given 4 options. U cos theta I cap plus u sin theta j cap, u cos theta I cap, third হচ্ছে u cos theta I cap plus u sin theta minus gt j cap, and fourth is none of this. So can you guess anyone? Ayush, can you hear me?
Yes, sir.
Can you guess anyone? But a velocity expression at the top point. Okay, no problem. Just listen. Shoram, just see at the top point, is there any vertical component existing?
No, sir.
So is there any existence of this u sin theta minus gt?
No, sir.
So this part is 0 though.
Yes, sir. Yes, sir.
So which one? Which one is
Option
correct?
2.
Option 2, right? Very good. Understood? No problem?
Yes. No problem.
Very good, very good. So you understood. Very good. Take. So this kind of just a simple example. Okay, fine. Now, see, can I just delete this one?
Yes, sir. Yes, sir. You can.
Yes, fine. Now see, just like see, a boy has projected a particle with the angle theta naught with the velocity u naught. A boy has projected a particle with a velocity theta naught, velocity angle theta naught and velocity u naught. And if it attains a speed, if it is attaining speed equal to root over 2/3 times the speed of the projection, it attains a speed of root over 2/3 times the speed of projection when the body is at the half of the maximum height. Want to tell you? Particle going this way This is the maximum height when it is reaching the half of the maximum height. Then it is achieving a velocity root over 2/3 u naught. Question, is the question clear? No.
Yes.
The velocity is here at this position root over 2/3 u naught when it is at the half of the highest point. If this is h, the maximum height is half. Okay, this is given information given. But then you have to find this angle theta naught. You have to find the angle theta naught. Is the question clear, Saurabh?
Yes, sir, it's clear.
Very good. So how can I approach this one? How we can approach the particle projected with the velocity angle theta naught when it is reaching the half of the height, maximum height, its velocity is 2/3 u naught. U naught is the initial velocity. So it's the thing. Okay, fine, very good. So how to approach this thing? From there we have to find the angle with which the particle was fired. Now see, this is the velocity u naught. So what is the vertical component? U naught sine theta naught.
Yes, sir.
What is the horizontal component? U naught cos theta naught. These are the two horizontal and vertical component, right? So now in this equation, right? So if I want to find the maximum height h, the formula just we found showed up. U naught sine theta naught squared divided by 2g. You see?
Yes, sir.
We found this thing, u naught, u square sine square theta by 2g. So initial velocity there, u naught. So we use that thing. Okay. So u naught sine theta naught square by 2g. So half of the height is h by 2. Money u naught square sine square theta naught divided by 4g. This is this height, this portion of the height, this much of here. Okay. Now what the thing is going to happen here, we can see that this position we have a horizontal component of, because this horizontal component is not going to change. Here the resultant velocity is the root over 2/3 u naught, and it is having a horizontal component u naught cos theta naught. This is existing. And in this position, in the vertical position, if I'm going to see the vertical velocity is Vy, suppose I'm going to think that at that point, vertical velocity is Vy. So how can I write? Vy square is equal to u naught sine theta naught square, u square minus 2a into h by 2. Sort of understanding? No.
No.
Acha, tell me. Acha, you tell me now. Whenever I'm going to throw a particle with the velocity u, if it is going to a certain height, suppose h, if this position velocity is v, we write v square is equal to u square minus 2gh. You write na?
Yes, sir. Yes.
Same formula we have written. Initial velocity u sine theta, u naught sine theta, u naught sine theta square minus 2g into what is the vertical displacement? H by 2. H, maximum height, half of the maximum height.
Yes, sir.
Clear? Very good.
Clear.
So this half and 2 cancels out. So we can write Vy square, velocity, vertical component of the velocity at this point. This is Vy square is equal to u naught square sine square theta naught minus g. Already we know that this thing h by value of the h we know. What is this value? What is the value? U naught square sine square theta naught divided by 2 into g. This h, Just we are putting this value.
Yes, sir.
So G cancelling out. Take. So now Vy square is equal to U naught square sine square theta naught minus U naught square sine square theta naught by 2. So finally, what we can write? Vy square is equal to U naught square sine square theta naught divided by 2. This is the at this position, half of the maximum height. At this position, vertical component of the velocity have this kind of expression. Is it clear or not clear?
Yes, sir, it's clear.
Clear? Very good. So now, this horizontal component U naught cos theta naught already existing though. U naught cos theta naught already existing. Horizontal component. This is not going to change. Huh? So resultant velocity at this position, resultant velocity is like this way. This horizontal component square, vertical component square is equal to resultant square. So what is the resultant? Root 3 by 2 U naught. So therefore we can write it is square is equal to horizontal square U naught square cos square theta naught plus this much vertical component square U naught square sine square theta naught divided by 2. Sure of understanding or not? Sure of?
Yes, sir, got it.
Understanding
Yes,
na? Very good. So 2 by 3 U naught square is equal to just take the U naught common and cos square theta naught plus sine square theta naught by 2. So here U naught square cancelling out. So what is coming? What is coming? 2/3 is equal to, just put the 2 here, 2 cos square theta naught plus sine square theta naught by 2. So now if I just going to just split this one, 2 cos square theta naught plus sine square theta naught. 2 cos
Yes.
square theta naught plus sine square theta naught means মানে cos square theta naught plus sine square theta naught মানে 1 plus cos square theta naught 2 cos square theta naught plus sine square theta naught মানে cos square theta naught plus cos square theta naught plus sine square theta naught. So this part is going to become 1 though. ঠিক না? Isn't it?
Yes. Yes, sir.
Yes. So therefore we can write 2/3 is equal to cos square theta naught plus 1 divided by 2. So now this 2 I'm just multiplying this one with this 2, this cross multiplication. So what it will come? What it will come? Oh, right. Oh. This is going to become 4. Clear? Therefore, cos square theta naught is equal to 4/3 minus 1. Mane cos square theta naught is equal to 1/3. Therefore, theta naught, mane cos theta naught 1/√3.
Okay, sir.
Sort of understanding this point, isn't it?
Yes, sir, got it.
Got it, na? Very good, very good, very good. Okay, very good. Now, see. Acha, can I change this? If any confusion, Saurabh asks me.
No, sir, no confusion.
No confusion? Very good. Very nice. Now, see. I'm changing the page.
Yes.
Suppose from a vertical height h, a particle is projected horizontally with a velocity u. A vertical height h existing. So suppose a tower. From the tower, a particle projected horizontally. Check. No problem.
Yes, sir.
So now what the thing is going to happen? That object will strike the ground like this manner.
Yes, sir.
Yes, very good. Now what the thing is going to happen, Shora? If I take this is the x-axis and this one is the y-axis, so it has gone down. Huh?
Yes, sir.
Shora, can you tell me, is there any component of the velocity along y-axis initially?
No, sir.
No, no component, isn't it? So
Yes, sir.
if I just consider the vertical motion, huh, what is the net displacement? H, vertical displacement. Initial velocity vertical is 0. Initial velocity vertical is 0 initial, and when it is reaching the ground, the displacement is h though. ठीक ना?
Yes, sir.
Sure up?
Yes, sir.
Very good. So now final displacement, vertical final displacement is h. So is equal to ut plus half gt square. U to 0, so we are cancelling this one. So I can write h is equal to half gt square, because since x component and y component of x and y are mutually perpendicular with each other, x and y, therefore whenever I'm discussing the y-axis motion, vertical motion, we need not require to think about what is happening along x. So we are writing simply y-axis equation, vertical equation, h is equal to half gt square.
Yes, sir.
So therefore the time required to reach the ground is equal to 2h, and just put the g down, is equal to t square. Therefore t is equal to root over 2h by g. Time to reach the ground.
Yes, sir.
Heck, very good, very good. Okay, very nice. Okay, so we found the time. So now, Saurabh, can you tell me what is the horizontal length it has moved? Horizontal length it has moved?
Sir, u cos theta.
U cos theta. U cos theta into time, isn't it?
Yes, sir.
So, but here is no cos theta. Is there any angle information given? No.
No, sir.
So therefore, this u, the horizontal velocity, is the actual velocity in the horizontal direction. We need not require to think about the cos component.
Okay, sir.
Clear? Understanding now?
Yes, sir.
So therefore, this horizontal displacement, it should be, suppose range r. That range we can write u, horizontal velocity, u, into this time, total time required for the particle to reach the ground, we previously found. So into t. So r is equal to u into root over 2h by g. This is the result. This length.
Okay, sir.
Understood properly, Saurabh?
Yes, sir. Understood.
Understood now? Very good. Acha, can you tell me, Saurabh, what is the displacement of the particle? It has gone, it is started from here, it is striking here. What is the displacement? If I join this line, initial point and final point, that will be the displacement?
Yes.
So how can I find this displacement? We got the horizontal range, this much. We got the vertical height, this much. So if I want to find the this displacement, this line, so
Yes.
because this is the 90-degree right angle triangle.
By Pythagoras we can find.
Yes, Ayush, right, ekdam. So quickly find h square plus range square root na, Saurabh?
Yes.
Height square plus range square root. This is the displacement in this situation. Take na?
Yes, sir.
Very good. So already we found the range here. Expression of the range we found. we can put that range, value of the range, we can directly put it here. So r square means what? What is the value of the r square? We can write like this way, u square into 2h by g. That I can put it here.
Yes.
The root over h square plus 2u square h by g plus. Understanding my point or not?
Yes, I got it.
Got it, na? So this kind of question can be asked. They can give this kind of question. Acha. The next part of this portion, the particles striking the ground in an inclined manner. You can see, just like striking the ground in an inclined manner.
Yes.
So what is the inclination of the velocity theta? What is the inclination of the velocity theta with the horizontal direction when it is striking the ground? Is the question clear? What is the inclination theta with the horizontal when the particle is going to strike the ground? What is the inclination? This is the question. How can I find? Ayush, how can I find? Any idea, Ayush? Saurabh?
Sir, could we apply the formula that tan alpha equal to u sin theta minus
Tan
ct by
concept of the tan we have to use, but directly that formula we are not going to use. We are going to find a tan. That is okay. Up to that point, you are correct. Actually, you have to see what is the vertical component of the velocity and what is the horizontal component of the velocity. That two components we require. If I know the vertical component and if I know the horizontal component, then ratio of that vertical to horizontal, this is the tan theta we can find.
Yes.
Isn't it? So what will be the vertical component of the velocity? Vertical component, you can see whenever the particle started downward motion, vertical motion, initial velocity 0 at this point, isn't it? Tale, a final velocity is what? Vertical final velocity. V is equal to vertical y-axis velocity, Vy, g into t na?
Yes.
Because u0, v is equal to u plus gt, u0, vertical component initially 0, so Vy is equal to g into t, and we already know the time. The time when it is going to come this position, that time already we found though.
Yes, sir.
Ayush, understanding my point? Ayush?
Yes, sir.
Right, very good. So already we found the time. So we're going to put the time there.
Sir.
Vy, velocity along y-axis, that is going to become g into this time. Money root over 2h by g. Is it clear? So root g in the denominator and this g in the numerator, they're cancelling out. The result is going to come root over 2gh. Because root g and g, if I cut, so one another root g is existing in the numerator portion. So ultimately, velocity along y-axis, and when it is particle is going to strike the ground, it is having this much, root over 2gh. Is it clear?
Yes, sir.
Very good. Ayush, clear now? No problem.
Yes, sir.
Very good. So can you now tell me what is this inclination? Vertical velocity and horizontal velocity ratio, that is the tan theta. So we can write tan theta. What is the vertical velocity? Already we found root over 2gh. Root over 2gh divided by what is the horizontal component? U is the horizontal component, and along the horizontal direction, since there is no acceleration or retardation, horizontal component is not going to change. Just like
Yes.
previous one, horizontal component is not going to change. So horizontal component u. So tan theta is equal to root over 2gh by u. Tan theta root over 2gh divided by u. This is the angle with which the particle is going to strike the ground. It is making that this much of angle with the horizontal direction. Is it clear or not clear, Saurabh?
Yes, sir, it's clear.
And Ayush, is it clear?
Yes, sir.
Very good, very good, very good. Acha, can you tell me, Ayush and Saurabh, what is the net uh, what is the net velocity at this part, in this part? It is striking the resultant. I want the resultant. Because we found a horizontal velocity, we found a vertical velocity. We should have a net resultant, na? Just like vector addition.
Yes, root over of
Root.
horizontal square plus vertical square.
Yes. So horizontal velocity square plus vertical velocity square root is the resultant. Tick.
Yes.
তাহলে what is the vertical velocity vy? If I square it, root over 2gh square, মানে শুধু only 2gh plus u square horizontal. So let 2gh root over 2gh plus u square. This is the final velocity with which the particle is the final resultant velocity with which the particle is striking the ground. Is it clear or not clear, Saurabh?
Yes, sir, it's clear.
It is clear. Very good. Fine. Very nice. So now, just like see, up to this point, it is clear. Very good. If still, if have anyone having any cause of confusion or doubt, you can ask me again. No problem. Very good. Okay. Now, write a question. Write a question.
Okay.
A fighter plane moving with a speed. A fighter plane moving with a speed 50 root 2 meter per second. 50 root 2 meter per second. Making angle 45 degree with the vertical. एक फाइटर प्लेन है, it is moving upward, making angle 45 degree. ठीक. वेलोसिटी कितना है? 50 root 2 meter per second. Okay. Now, at a height 1000 meter from the ground, when the plane is at a vertically 1000 meter from the ground, it releases a bomb. Just India Pakistan is fighting. A fighter plane just moving vertically, making angle 45 degree with the vertical and horizontal both, and it is having a speed 50 root 2 meter per second. When it is vertically at 1000 meter, it releases a bomb. Check. Now you have to find the time of flight of the bomb. You have to find time of flight of the bomb. This is the first question, egg number question 1. And question 2, another question is there. Question is there, the maximum height of the bomb above the ground. Question 2 is what is telling? Maximum height of the bomb from ground. These are two questions. These are the two questions. Saurabh and Ayush, is the question clear?
Yes.
Okay. Will I help?
First we will try.
Okay, try a little bit. Ayush, are you trying? Just one hint I will give. One hint, not extra. Whenever the bomb released, whenever the bomb is released, because the plane was rising at the angle 45 degree with this much of velocity, bomb will just start moving in that direction, making angle 45 degree with the same speed. You just understand that thing. Initial. Clear? Money from a height 1000 meter, bomb start like this way. 50 √2, and it goes this way, it reaching a maximum height, and after traveling it is going to come down and going to strike the ground in this way.
Okay.
We require the total time of flight.
Sir, here we take G as 10, sir.
Now little bit hints I'm just going to give. Now see, show up. Listen. Initial velocity vertical direction is what? This direction? Initial
Yes,
velocity? But ultimately, if I just consider the vertical motion, it has moved downward.
Yes, sir.
So, initial vertical velocity upward, but displacement downward. So, we have to put the downward displacement as negative, minus.
Oh.
The equation with me, just like see, we find now h is equal to ut minus half gt square, we write now.
Yes, sir.
Whenever we throw a particle upward direction, this kind of equation we write, though h is equal to ut minus half gt square, isn't it?
Yes, sir.
But u is the upward velocity, but h is the downward displacement. So we can write like this way. Minus 1000 is equal to u sine 6 sine 45. Sine 45 means 1 by √2, isn't it? So this direction
Yes,
velocity is 50, and cos 45, this direction velocity also 50, because cos component, sine component, this is 45 degree. তাহলে 50 into t minus of half g এর value you can take 10 t square. Sort of understanding my point?
Yes, I got it.
So displacement minus 1000, 50t minus half g t square. So final equation is going to become 1000 is equal to 50t minus 5t square. So just this 5t square and 50t, if I just going to put in this side, so what the result is going to come? 5t square minus 50t minus 1000 is equal to 0.
Yes, sir.
So it is a quadratic of time. It is a quadratic of time. Understanding, Saurav?
Yes, I got it.
Very good. Ayush, understanding? Ayush? If you have confusion, Ayush, you ask me.
No, sir. I'm
Understanding now why we put this negative sign? Because initial vertical component is upward, this is 50, but displacement is downward, that's why we put it the minus 1000.
minus 1000.
Okay, so
Okay.
50t minus half gt square. Bas. Okay, so, now we just expressed the total thing as a quadratic form. Now 5 is there. 5 can be cutted. So 5, if I'm just eliminating 5, so what the result is going to come? T square minus 10t minus, if I divide the 1000 by 5, what the thing is going to come? 200. Right?
Yes.
Yes. Now solve it. Now we just going to solve this thing not by middle term factor. We directly use the Siddharacharya. You know everyone, ax square plus bx plus c is equal to 0. Then x is equal to minus b plus minus root over b square minus 4ac divided by 2a, isn't it? So we are going
Yes.
to use this thing. Therefore the t is equal to ax square minus of minus 10 plus minus b square x square plus minus 10 whole square b square minus 4 into a 1 into minus 200 divided by 2 into a. Okay, so
Yes.
minus plus 10, then plus minus root over of 10 square means 100
100.
and minus 4 into minus 200 কত হয় প্লাস মাইনাস প্লাস কত হচ্ছে 0 0 4 দুগুণে 8 800 ডিভাইডেড বাই 2 তাহলে 800 প্লাস 100 মানে 900 900
Yes.
root over 900 means 30
30.
30 very good তাহলে the result is plus 10 then don't take minus sign here because two solutions is going to come now, plus minus. If I take the minus sign, the time will come negative. Negative time is no value. Negative time is no value because whenever it is projected like this way, only one single time this particle is reaching is this point. Bomb is only one single time it is reaching this point. So only one single time you have to find from here. So we are going to take only plus value, plus 30 by 2. What I told, understood, both of you?
Yes. Got it.
Just only not the negative time, because if I take minus 30, the total time will come negative, no value. The time negative one, it doesn't matter. So 30 plus 10, 40 by 2, it is going to become 20 seconds. Mane total time of flight for the bomb to reach this point is equal to 20 seconds. Is it clear or not clear?
Yes, sir, it's clear.
It is clear. Very good, very good. Now the remaining portion, can you solve? What is the maximum, what is the height of the bomb from the ground? Maximum height. What is the maximum height of the bomb from the ground?
Yes.
We can find this height by our previous formula, just what we have solved. U square sine square theta by 2g, just we have done.
Yes, sir.
Saurabh?
Yes, sir.
You can see AJ, U square sine square theta by 2g, isn't it?
Yes.
So after using that formula of this height, if I add 1000, because it was projected from a height of 1000, because plane was released the bomb at a height 1000. So this height plus this 1000 will be the maximum height of the bomb from the ground.
Yes.
I think you understanding. So Ayush also understanding, I think so. Ayush understanding or not?
Yes, sir.
Now are you understanding what is the maximum height, just what we found?
No, sir.
Now I am telling that you can find this height. What is the formula? U square sine square theta by 2g. Saurabh knows. U square sine square theta by 2g is the maximum height in this level, plus the 1000. This 1000 is this height from where the bomb was released.
Okay, sir.
So this height, if this height is h, we can write U square sine square theta divided by 2g. Okay, and U sine theta whole square. U sine theta is what? 50. মানে
Yes, sir.
50 whole square divided by 2 into g মানে 10, মানে 50 into 50 by 2 into 10, isn't it? So it's cutting, and what the above it is coming, 50 into 1 মানে 250, 50 ছিল 5 মানে 25, 250 by 2 মানে 125. This height is 125, this much. So what is the height from the ground? 1000 plus 125, isn't it?
Yes, sir.
1000 plus 125, 5211, তাহলে total height maximum 1125 meter. This is the maximum height of that bomb. When the plane released that bomb, that is going up and again coming down, so that is the maximum height, 1125 meter. 1125 meter is the maximum height the bomb is going to reach, and the time required to come to the ground is equal to 20 seconds.
Okay.
So I think, Saurabh, it is clear, na?
Yes, sir. It's clear.
It is clear. Very good. And Ayush also getting something. Ayush,
clear.
clear. Very good. And just you go through the previous lectures also, Ayush. Okay. Just whatever the class taken now. If you go through the lectures and if you have the doubt, you can ask me again. Then I will solve it. I will tell you. So you have to go through all the lectures I've given in the Vidya Nest. So you just, that recorded part you just see, and whatever the doubt arising, you ask. No problem. Okay, understanding na? I think Ayush understood.
Yes, sir.
Okay, very good. Okay, so this is our projectile motion. Okay. And Saurabh, you start doing the numericals. If you have the doubt, you can send here. You start the
Yes,
numericals. What is the textbook you are following, Saurabh?
let's see what.
Okay, you can start from there. And also whatever the I am doing here, just you follow. It will be clear for you. There will be no problem.
Okay, sir.
Okay. Okay, Saurabh. So today we are going to end. Okay, students. Okay.
Yes.
Okay.
Yes,
Okay.
sir.